Alright, so let's continue solving algebraic equations. Again, as we've seen many times in these videos, it's a matter of identifying what you have in your equation and then knowing how to proceed with what you see. So when I look at this equation right here, I'm looking to see, do I have fractions, radicals, absolute values, anything that kind of stands out to me? And I don't see that. I have a bunch of stuff that's connected together through multiplication, and then I have 0 on the other side. Well, since I have 0 on the other side and everything is factored, this is a prime example for using the zero factor theorem. So the zero factor theorem says if you've got a bunch of stuff that's multiplied together and it equals 0, that means that one of these guys has to be 0. So it means that 3x is equal to 0, or the next factor, 6x plus 19, equals 0, or x minus 104 is equal to 0, right? If you multiply to equal 0, somebody has to be 0. One of those factors has to be 0. And so what you do is that you take this ugly looking problem and you break it down into 3 small, simple little equations to solve. So this one right here, surprisingly enough, this is where a lot of students have problems. They get confused about how to get x by itself. Well, you know, what if I did this? If I just had that, if I say 3x equals something, and I said, how do you get x by itself? I think most of you would say, oh, just divide both sides by 3. So let's do that. Divide both sides of the equation by 3, and x equals, well, 0 divided by 3 is just 0. So there is one solution. For the middle one, if you subtract 19 on both sides, now, if you don't want to show that step, that's okay. It's a really basic step. But if it's one of those steps that's causing you to have problems when you don't show it, then make sure you show the step. Do what's going to work for you here. Right? So typically I don't show that. I would just say 6x equals negative 19, and then divide both sides by 6. So x equals negative 19 over 6. Simplify if you can, but there's nothing to do here. So it stays like that. And finally over here, to get x by itself, you add 104 to the other side. So x equals positive 104. So you get one solution for each of these factors, and you're done. Nice and simple, no need to sweat about that one. And let's look at the next one. Let's see how it's similar yet different. In this next problem, we have a factorization, and it's equal to 15. Now, in the last problem, we had a bunch of factors, and it was equal to 0. And so since it was already equal to 0, we could set each factor equal to 0. But since this is equal to 15, there's no guarantee about these guys. If I tell you that you multiply two numbers to get 15, you don't know, you don't have any guarantee what one of those numbers has to be. It could be that one number is 1 and the other is 15, but it could be that one is 3 and the other is 5. It could be that one is 30 and the other one's 1/2. You have no guarantee. The only guarantee is when you multiply to get 0. When you multiply to get 0, one of those factors has to be 0. It's just a guarantee. So here, we can't do what we did in the last problem just yet. We're going to have to somehow get everything to the same side and get 0 on the other side, and then see if we can factor or maybe complete the square, quadratic formula, something like that. But before I move the 15 over, I need to have a place for it. So right now, everything is kind of all in the little boxes in the factorization. So I need to expand that so that when I bring the 15 over, I know exactly where he's going to go. So let's FOIL this out. So 2x times x is 2x squared. 2x times negative 5 is negative 10x. 3 times x is positive 3x. 3 times negative 5 is negative 15. And then I still have the positive 15 on the other side. All right, well, I said we need to get everything to the same side. And so now, when I try to subtract 15 on both sides, I have a place for that negative 15 to go. I'll put it with its like term. And so I do that, and then I take all of the stuff that's on the left side and I condense it. I simplify. So now I have 2x squared. Negative 10x plus 3x is a negative 7x. Negative 15 minus 15 grows to a negative 30. And now on the right side we have 0. Well, if we think about the procedure that we have for solving quadratic equations, the first thing you would try to implement would be the square root property. But I can't do that because I have two terms that contain the variable. All right, so that doesn't work. So I look at the square root property, and that's a no-go. What about the zero factor theorem? Can I do anything with that? Well, to see if the zero factor theorem works, we're going to have to do the AC method because the lead coefficient here is not 1. So for the AC method, that means to do 2 times 30, and I get 60. And then I need to look at 60 and see, are there factors of 60 that subtract to 7? Okay, so this is how I do the AC method. I'm not going to worry about the sign of the 30 right now until I'm looking at finding factors of the AC product. I want them to subtract to 7. And so when you go through the progression for 60, what numbers will multiply to give you 60? Eventually you land on 5 and 12. So 5 times 12 is 60, and those two factors have a difference of 7. And so what I'm going to do is I'm going to rewrite that negative 7x using the 5 and the 12. So this is 2x squared, 5x, 12x, minus 30 is equal to 0. And now we've got to make sure that we pay attention to the signs. So in order to get a negative 7x, the larger number must be negative. And in order to make sure that it's a 7 and nothing different, we're going to have a positive for the 5. So positive 5 and negative 12 will give me the negative 7 here. Now what we should be able to do is, since we have 4 terms, we should be able to factor by grouping, and it should work out without any kind of problems. So in the first group, we have a common factor of x. So I've factored that out, leaving me with 2x plus 5. In the second group, notice that I lead off with a negative, so factor out a negative, and the common factor for 12 and 30 is 6. So I'm going to divide out the negative 6, and I'm left with 2x plus 5 yet again, which is exactly what we want. Okay? So this is your big common factor. So that's going to go in front, so 2x plus 5 times x minus 6. Alright, so we have this factor. It's equal to 0. So we're going to take each of these factors and set them equal to 0 using that zero factor theorem. So that means 2x plus 5 must equal 0, or x minus 6 equals 0. Again, we only have the guarantee if the product equals 0, not 15. So let's solve each of these. So here 2x is equal to negative 5, which means x equals negative 5 halves. And then over here you add 6 to both sides, so x equals positive 6. So here we go. Just like that. And we're done. Now let's see what else we have in store. Alright. So let's take a look at this equation. X squared plus 22x plus 170. So, it's a normal looking polynomial equation. It's a quadratic equation because we see we've got the x squared, the x, and the constant. Okay, it's already equal to 0, so that's a good setup for us. So let's go through our progression. Can I use the square root property? Well, I've got 2 instances of the variable, so the answer here is no. Well, what about factoring? Can I find factors of 170 that add to 22? Now you can go through the entire list of 170's factor pairs, but you won't find a combination that gives you 22. So factoring does not work. And what about completing the square? Is that something that works here? Well, let's see. For completing the square, you want the lead coefficient here to be 1. It is. And you want the middle coefficient to be even. And it is. So that tells us that completing the square is going to be the best method for us to use here to solve this quadratic equation. So let's go through the procedure for completing the square. So the first thing we need to do is move this 170 to the other side. So right now this 170 is just kind of in the way. So just move it to the other side. When you do this, make sure you leave a gap, and we're going to fill that in here in just a moment, and this equals negative 170 on the right side. So the next thing we have to do is we have to figure out what goes in this gap to create a perfect squared trinomial on the left side. Now there are a lot of numbers we can put here so that the left side factors, but we want to put a very specific number so that the trinomial doesn't just factor, but it factors as the exact same two factors, which would combine to something that's squared. So if you look at some textbooks, if you look at other videos, if you're in my math lab, it's going to do it a slightly different way. So I go ahead and I go to the factorization because I know that's what's going to be my next step. And the reason I do that is because the process for getting this number also gives you the number that goes in the factorization at the same time. So I say just do it all together. So to get this number, you take this and you divide it by 2. Now, you're still going to have 22x, but inside here you're going to write half of that, which is positive 11. And to get the number that goes here in the gap, the number that completes the square, you actually square 11, which is 121. So by adding 121 here on the left side, I create a perfect squared trinomial which factors as x plus 11 times x plus 11, or in this case we write that as x plus 11 quantity squared. So we needed 121 here, but by adding 121 to the left side we've changed the problem, unless I maintain balance and I add 121 to the right side. So the 121 that's on the left side is to help us complete the square. The one that's on the right side maintains the balance that we're supposed to have in an equation. Alright, so when I combine these terms on the right side, that's negative 49. So I go from having this quadratic equation to something that's a little bit nicer for us, because instead of having two instances of our variable, we just have this guy right here, and he's contained inside of a square. And that's the big idea about completing the square, is that you manipulate the equation so that you can use the square root property. So let's take our trusty light blue pen and apply a square root on both sides of the equation. Remember that when you do this, when you are the one who's putting the square root in the problem, you instantly put plus or minus. You don't wait till the end to do plus or minus, you do it right then and there. So on the left side, the square root and the square cancel each other out, so to speak. On the right side, we have plus or minus. The square root of 49 is 7. And the negative that's inside of that radical becomes I on the outside. So yes, we're going to have answers that are imaginary. And then with our last step, we're going to subtract 11 on both sides. So x is equal to negative 11 plus or minus 7i. So a key thing here, the key things are making sure that you move the constant to the other side. Whatever number you add here to complete the square, you have to add that to the other side. And make sure that you factor correctly, right? But again, I say the trick is to do the factorization, find that 11 first, before you square this number that tells you how to complete the square. It just kind of makes it a little bit easier. We get our two answers. We know we were supposed to have two answers because this is a square. So the degree of the polynomial tells you how many solutions we're supposed to have. Even though these are imaginary, they are still counted as solutions. So don't neglect them. All right, let's do one more problem here. Let's take a look at the quadratic equation, 5x squared plus 2x minus 1 equals 0. Now, I said quadratic. Maybe I kind of spoiled it for you. But we should be able to look at this and realize that when you have x squared, x, and a constant, that this is your classic quadratic equation. So we go through that progression to figure out what's going to be the best method for solving this. All right. So can I use the square root property? Well, I have two instances of the variable, so the answer here is no. Then I'm going to try to factor. Let's see, maybe I can do something here. Well, I'd have to do the AC method. So 5 times 1 is 5, and are there factors of 5 that subtract to 2? No. No, because all you have are 1 and 5, and that's not going to do you any good. So factoring is out of the question. What about completing the square? Let's think about what completing the square asks us to do. It wants this guy to be a 1. It's a 5 right now, but we can get it to be a 1 by dividing everything in the problem by 5. However, once I start dividing by 5, I'm going to create fractions here, which then just complicates completing the square later on. So even though you can complete the square, it's not going to be as easy as it should be. The last problem, completing the square, worked great. This one, not so much. Which means the method of last resort for us is the quadratic formula, and that's what we're going to use here. Now, to use the quadratic formula, we need to identify our a, b, and c. So a is 5, b is 2, and c, the constant, is -1. Make sure that when you are identifying your a, b, and c, that you have everything on the same side of the equation, and you really want this coefficient to be positive. If it's not, then just multiply both sides of the equation by a negative, and it's going to clear that up for you. Whenever you use the quadratic formula, you need to write the quadratic formula. I don't care if other people make fun of you for writing it every time. You're going to be the one who actually knows the formula. So, what's the formula? Well, it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Notice that the fraction does not extend underneath the x and the equals. That's just wrong. And the fraction is not inside the radical. The radical is in the numerator of the fraction. Okay? All right, so let's plug in what we have. So x is equal to fraction. So -b means -5 plus or minus the square root b squared. All right, so why did I say -5? It's almost like I'm not even paying attention. Got to pay attention here. All right, so we're just going to pretend this didn't happen. I know mistakes never happen for you guys, so it must be nice to live that kind of life. What I meant to say was, this is why I have it labeled, -b is -2 plus or minus the square root b squared, so b is 2, b squared is 4, minus 4ac, I circle this whole guy right here. So this becomes -4 times a, which is 5, times c, -1. And that product, -4 times 5 times -1, is a positive 20. And this is all over 2a, so 2 times 5 is 10. All right, so the rest of this is just a matter of cleaning things up and simplifying. So we have -2 plus or minus the square root of 24, all divided by 10. Now you've got to make sure that you avoid the temptation of trying to reduce the 2 and the 10 right now, because the 10 is a denominator for 2, but it's also the denominator for that radical. So we need to simplify the radical first. The radical can be broken down to 4 times 6. And so when we look at these, the square root of 4 becomes 2, but the 6 has to stay inside the radical. So x is equal to -2 plus or minus 2 square roots of 6, all divided by 10. And we also want to make sure we pay attention to the fact that there is a common factor for all of these guys, and that common factor is 2. So when you reduce this, you end up with -1 plus or minus the square root of 6, all over 5. And there we go. So you may be saying, well, how did you reduce that? Well, I said there was a common factor, right? And so what we have here is this. Let me just kind of write this over here on this side so you can see a little bit better. We had negative 2 plus or minus 2 square roots of 6 over 10. Everybody here has a common factor of 2, and I can rewrite this by factoring out the 2. If I factor out the 2, I get negative 1 plus or minus the square root of 6. In the denominator, if I factor out the 2, I'm left with 5. Okay, so I do this, and I can see that these are the common factors that get to reduce, leaving me with the negative 1 plus or minus the square root of 6 over 5. And so there you go. There you have it. So for each of these equations, especially things that are quadratic, you go through this progression to figure out what's going to be the best method to use. If you can use the square root property, do it, and it's going to be easier than anything else below it. If you can factor, do that, because it'll be easier and quicker than the rest of these. Quadratic formula is something that a lot of students try to do at the beginning for everything, but really, this should only be used when nothing else works nicely.